So section 9.2, paired samples for two means. So are two populations the same? So is the average height of men taller than the average height of women? Is the mean weight less after a diet than before? So when quantitative data have been collected, you can compare populations by comparing their means. Okay, so again, we have this kind of running theme through the entire course as an intro course. Every time we have quantitative data, we're going to be focusing on means, and for qualitative data, we're going to be focusing on proportions or percentages. And so we can take a sample from each of those populations and then compare their statistics. So anytime you compare two populations, we need to know if the samples are independent or dependent. So the formulas we use are different for different types of samples. So what is the difference between these two? So it's easier to identify if two samples are dependent or if they've been matched in some way. And then if they're not that, then they have to be independent samples. So as we gather data from samples, it's one or the other. And again, dependent is easier to identify. So dependent or matched pair samples. So these are samples that have been matched based on some criteria, or samples in which two measurements were taken on the same object, one before and one after some particular treatment. So here the individuals in one sample dictate or determine the individuals in the second sample. So in this case, we have two values of the same variable recorded for the same object or similar objects. So a lot of these that we're going to see are going to be in this before and after scenario. So like up here where they talked about the diet plan. So if we take a bunch of people and we may weigh them before they go on a diet, and then we take those same people and we weigh them after the diet, we're going to have two values of weight, the same variable, recorded for each of those objects in the sample. So those would be paired samples. So if they have not been matched in any way, it's not a before-after type study, okay, then we've got independent samples. So this is when the individuals in one sample do not dictate or determine which individuals are to be in the second sample. Okay, so in this case, we have two values of the same variable for two different objects. That have not been matched or paired together in any way. So in the case here where we were talking about the height of men versus the height of women, if we randomly select a group of men and measure all their heights, and then randomly select a group of women and measure all their heights, okay, we've got two different groups here that we're measuring the same variable height for, but they aren't matched in any way. So it's not before after. We haven't matched some male with a female based on any other criteria. So those would be independent samples. So let's look at a couple examples and trying to determine what scenario we have. So example 9.2.1, so independent or dependent samples. And again, keep in mind this is now creeping in on us here because now we're looking at two groups. When on the last two chapters we only had one group of data, so we didn't have to ask ourselves if we had independent or dependent samples because we only had one sample. So determine if the following are dependent or independent samples. So for part A, it says we're going to randomly choose 5 men and 6 women and measure their heights. Okay, so in this case, these men and these women obviously are not the same people. Okay, so it's not like some before-after study where we have two measurements on the same individual. And they didn't say anything about matching them based on any criteria, and there's no way they could be matched because we have 5 men and 6 women, so the sample sizes aren't the same, so they couldn't have been matched or paired in any way. So our solution here, we're going to write here, so the individuals are not the same. For both samples. And the 5 men have not been paired on any criteria with the 6 women. So these samples are independent. Now if we look at part B, it says to choose 10 men and weigh them, give them a new Wonder Diet drug, and then later weigh them again. So in this case, we're going to have 2 weights on each of these 10 men. Okay, so each person's before weight can be matched with their after weight. Okay, we have, so in this case we do have 2 measurements of, in this case our variable is weight, on the same person. So these samples are dependent. Alright, and then the last case here is if we take 10 people and measure the strength of their dominant arm and their non-dominant arm. So in this case, although we're taking measurements on 2 different arms, both of those arms are on the same person, and so how strong you are with one arm is probably dependent on how strong you are with the other arm. So in this case, 2 measurements of strength have been taken on the same person. So again, although the measurements for different arms, again, how strong a person is with one arm will depend on how strong they are with the other. Okay, so these samples are dependent.